So in this video, we are going to be taking a look specifically at finding the distance. All right, so we're going to be finding the distance between 2 points. So here I have a graph, and I'm taking a look at the distance between the two. Now, a lot of times we attempt to count the squares, and we go, okay, well, this is like part of one, and then that one and that one would make a full one, and it's not actually accurate. So we're going to take a look at how we can use the distance formula, but break it apart slightly different so it's easier to understand. All right, so first and foremost, you need to understand the distance formula is using the Pythagorean theorem. The reason is I can trace the grid lines. So I can trace my grid line here, and I can trace my grid line here. And notice I made myself a right triangle. So this distance here would be my leg A. This distance here is my leg B. And that means the distance that I'm looking for is the hypotenuse. So once it's on a graph, I can count the squares and I can say, well, 1, 2, 3, 4, 5, 6, 7 squares. So leg A is 7. And 1, 2, 3 squares is my leg B. Beautiful, great. However, there's one slight downfall. I don't always have graph paper. So how can I do this skill if I don't have graph paper? Well, the solution is easy. Notice my leg A is my up-down. That's my y values. Notice my y value of 2 and negative 5. If I subtract these two, I get the number 7. Now, in some cases, I'm going to get negative 7, but that's okay. Negative 5 minus 2 is negative 7. 2 minus negative 5 is positive 7. And given what we're going to be doing, the positive and the negative don't matter. Notice here, the 3 is going horizontally, which deals with my x values. Negative 2 minus 1, or 1 minus negative 2 will get me that 3. So a way that we can find out the number of squares up and the number of squares over is simply by doing subtraction. Okay, so to find the distance between 2 points, we can use the Pythagorean theorem. We're going to subtract the x's, subtract the y's, and that's going to become our two different legs. So again, to find the distance, we're going to subtract the x's, subtract the y's, and then plug it in. So many of you guys have seen the distance formula, and there's a big square root symbol going over top of this. And for the purpose of this, I'm not going to put it there yet. Notice in the real distance formula, it's distance equals, and there's no squared here because remember, to get rid of squared, we do square root. So I could put a square root symbol around here and cancel out the c, and I could put a giant thing here, but a lot of times that just gets confusing. So for what you need to remember is you need to remember subtract the x's, that becomes my a, subtract my y's, that becomes my b, and I plug it into the Pythagorean theorem. All right, so let's give this a try. Let's see how it does. Okay. All right, so we said we're going to subtract the x's, and I can work left to right if I feel. So I have 1 and I have 5, so I'm going to say 1 minus 5. So there's my x's. And I might just label this x's so I kind of remember what I'm working with. 1 minus 5 gets me negative 4. Now I'm going to subtract my y's, and I have to do it in the same order. So because I did 1 and then 5, I have to do 3 minus 7. Now I could have done the other direction, but 3 minus 7, which equals negative 4. Okay, so when I subtract my x's, I subtract my y's. And now what I'm going to do is I'm going to plug these in to my Pythagorean theorem, and then we're going to get our handy-dandy calculator out, and we're going to do the work. All right, so we're going to have negative 4 squared, there's my a, plus negative 4 squared, that's my b, equals c squared, because that's my Pythagorean theorem. All right, so I'm going to type it in exactly how I wrote it. Negative 4 squared, negative 4 times negative 4 makes a positive 16. Well, if that negative 4 squared is positive 16, this one has to be 2, equals c squared. 16 plus 16 gets me 32. And I ran out of room here, so I'm going to shift it over here. So 32 equals c squared. And now I'm going to take the square root because I have to cancel out my cancel out my squared. Now remember, 32 is not perfect. So if I type this into my calculator, second x squared, 32, I would get a irrational number, a number that never repeats, never terminates. So the actual answer to this, the distance between these 2 points, is the square root of 32. We can then say that it is approximately, and I could use this value, it's approximately 5.66. Okay, so go ahead and try this one on your own, and let's see how you do. So again, we have 10, 6, and 1, -4, and the question is, what is the distance between these 2 points? Okay, pause the video if you need any longer to do this. All right, so I'm going to subtract my x's, 10 minus 1, which gets me 9. And then I'm going to do 6 minus -4, which gets me 10. So now I'm going to plug this into my formula. 9 squared plus 10 squared equals c squared. 81 plus 100 equals c squared. 181 equals c squared. And again, that's not a perfect square. So my distance is the square root of 181. Or I can type it into my calculator and I can say the square root of 181 is approximately, so this distance is approximately 13.45, whatever my unit of measure is.